Lesson 33, Built-in Class Behavior. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. The extension of C to C++ has given C++ classes some built-in artifacts which we will want to keep in mind. In this video, we demonstrate some of the more prominent artifacts that exist and show how to eliminate them. We begin with a simple class that holds an integer and a member function to print its value. In the main function, we instantiate this class using the default constructor and an initialization list. We have seen code examples like this in previous lessons where the default constructor that is called does not assign the data member a value, so the value is left as a strange value, which we see by executing the program. Nothing new has been introduced so far, but it is important to note that we can create objects with a default constructor even though we did not put one in the class. Likewise, we can also use an initialization list. Continuing with this same class, we change the main function to this. Here we initialize one object with a copy constructor, and we use an assignment operator to set the value of another object. Executing the program, we see that the copy constructor and assignment operator copy the value of the int member, even though we did not create either of them in our class. Let's summarize what we have seen so far. Without any constructors or operators declared in our class, we have a default constructor, a copy constructor, an assignment operator, and we can initialize objects with an initialization list. Now we will disable this behavior. In our third program, we have added a constructor that takes an int argument and assigns our data member this value. Adding any constructor disables the default constructor and the use of our initialization lists. You should try this out to verify it. In our main function, we have added two instantiations. The first is a simple call to our new constructor. The second creates a temporary object and then copies it with the assignment operator. Note that the syntax of our temporary object uses the class name. Executing the program, we get this. Constructors like this one with only one argument get special treatment in C++. We can use the constructor directly with the assignment operator during initialization or when making an assignment. This program is equivalent to the last program, with these two statements being equivalent to the previous ones. Sometimes it will be desirable to disable this default assignment behavior. If we add the keyword explicit to our constructor, these assignment statements become unusable and will generate compiler errors. To summarize this behavior, we note that creating any constructor destabilizes initialization lists and the built-in default constructor. If we have a constructor which takes one argument, we can initialize objects or assign them values with it by using the assignment operator. This can be disabled by using the keyword explicit. Despite our int argument constructor, our class still has a built-in copy constructor and an assignment operator. In this program, we show an example of an object initialized with the built-in copy constructor and one that has its value changed by the built-in assignment operator. If we execute the program, we see this. Oftentimes, we will want to change the behavior of these built-in functions. To do that, we can write our own. However, we can also simply disable the copy constructor and the assignment operator by making private versions of them. In this program, we have a simple copy constructor and an assignment operator which is defined above the word public in our class. Putting these above the word public makes them private, which means they cannot be used. We will explain the exact meaning of public and private in our next lesson. This concludes the lesson.